In the first part of Section 2, we learned about finding relative extrema, both relative minimums and relative maximums. Sometimes we're going to want to find the absolute largest and absolute smallest a function can be. This is known as optimization. What we call these are absolute or global maxima and minima. F has an absolute or global minimum at P if f of P is less than or equal to all values of f. So now it has to be the smallest of all the values of f on a given domain. Similarly, it has a global max if f of P is greater than or equal to all values of f. So it's the absolute highest point on a given domain. Absolute global maxes and mins are sometimes referred to as global extrema or optimal values because they optimize the function. We may not always have relative extrema and we may not always have absolute extrema. What we're going to do is take a look at some of the following graphs and identify relative and absolute maxima, relative and absolute minima, any concavity, and then any inflection points, which is where the concavity changes. In our first graph, what we see is we have a graph that's increasing the whole time and always concave up. It does not change from increasing to decreasing or the other way around, so there is no relative extrema. Also, it does not change concavity, so there's no inflection point. Also, this function will always be increasing to infinity, so there's no absolute maximum, and it decreases and continues to get closer and closer to zero without stopping. So there's no absolute minimum in this graph. Our next graph, we clearly see we have something that goes from decreasing to increasing and is always concave up. So we do have a relative minimum at 2. Now the graph does not change concavity, so we do not have an inflection point. And not only do we have a relative minimum, it's also the absolute minimum because it is the lowest point on the graph. As we can see by inspection, we do not have any relative maximums, and this graph will continue to increase without bounds, so we don't have any absolute max. This graph has a little bit more going on. What we see is that it increases and then decreases, so we have a relative max. We have a relative min at about -1/2. We have another relative max just past 1, and we have a relative min at a little bit past 3. Now, we do have relative extrema, but as you can see, this graph increases without bound and decreases without bound, so there's no absolute extrema. We can see that our graph does change concavity a couple times. So we have an inflection point right around -1/2. We have another one a little bit to the left of 1/2. And then we have a third inflection point at about 2.5. Those are the locations of the inflection points, not their value. The location is the input, the value is the output of the original function. Our final graph, we see that we have 2 relative mins and 1 relative max, as well as 2 inflection points. Our relative mins, one of those is an absolute min because it's the lowest point on the graph. Our relative max is not an absolute max, and in fact this graph does not have an absolute max because it continues to go up without bound. Here we have a graph that's increasing the whole time, so it has 2 horizontal asymptotes. This graph does not have any relative extrema, nor does it have any absolute extrema. It does change concavity though, so it does have an inflection point.